All right, so last notes of the year. We're solving natural log equations. And when they talk about natural log, they'll actually do it backwards. When they talk about natural log on your calculator, that's going to be the LN button. They actually, it's kind of, I guess it's, I don't know if it started French or Spanish. Anyway, it's the language it started in, they do it backwards. So it was log natural. I think we looked this up one day just to be funny because I was always being funny that it was, log natural. It actually was. It's French. So it's actually log natural when they go through this thing. On your calculator, if you've got the Texas Instruments, if you look at log that's here, if you look right underneath it, there's your LN button. So when we talk about LN, that's what we're talking about. Sometimes you'll see LN like that. Sometimes they'll do it like cursive, where it's like LN, kind of like that. But I think most of the cases you're going to see it, it's going to look something kind of like that when we go through those. All right, so here's the big thing. Now, with the natural logs on this one, with everything that's going on with this one, natural log uses base E. And the thing, base E is the reason I call it a natural log base is that when they started working with numbers, it's just one of those numbers that kind of pops up. E, if you go back and use it on your calculator and check it, and we'll show you where the E button is here. The E button for this one is right behind the LN. It's in green. So for that one, you hit your second and the LN button, and it gives you E. If we do E to the first power, that tells you that E is 2.7182818. So basically, it's about 2.718. And it's just one of those numbers that just pops up a lot of times when you're working with money or you're working with the way certain things happen. E is one of those numbers that just kind of naturally happens, just like when you're working with circles. 3.14 it just pops up when you start comparing your radius and your circumference and diameter, and you start working with all these different things. 3.14 pops up with pi. E, the 2.718 is one of those numbers. It just kind of naturally pops up. So they said, all right, well, since that number just kind of naturally happens when we start working with things, they call it the natural base because it's just one of those numbers. That's the way it works for these. So natural log uses base E. Now, when you're doing these, you won't see log base E. They don't write it this way. Then instead of log base E, they say, all right, we're just going to make it short. We're just going to put LN. So whenever you see LN, just realize that would be like log base E. And again, you won't see log base E. You're just going to see LN, which is the same thing as seeing that. You just don't see log base E. They're just going to use LN in its place. Okay, so everything we're doing when we're working through all the parts and pieces on this one, with everything that's here, is that the properties, all the solving, everything we're doing is basically the same thing. So if we kind of go back to before we get to the actual solving part of it here, if you back up to the properties, and again, you don't have to write, I'm going to put this over on the side, that the other day we were doing log of x plus log of y. Actually, I think we went backwards. Hold on. Again, what's in pencil, you don't have to write this part down. This is just me kind of going backing up here. If you remember a couple of days ago, when we had log of x times y, how we could expand it to make it log of x plus log of y. Well, we're going to do the same thing with the properties, but this time you're going to do it with ln. So it's the ln of xy. And it says, all right, well, if you expand that, my pen's down. That if you expand those properties on this one, that's going to be the ln of x plus the ln of y. Okay. And when we were doing division, we had log of x divided by y, made it log x minus log y. Well, over here, we're going to do the same thing. We're going to do the ln of x divided by y. That's going to be the ln of x minus the ln of y. So it's the exact same properties we did 2 days ago. Just the only difference now, instead of the word being log, now we're going to use ln. And same thing when we did log of x to some power. we wrote it as p times the log of x. Well, same thing here. If you do the ln of x to some power, it's going to be p times the ln of x. So all those properties that we were doing 2-3 days ago, it's the exact same properties again, but now instead of using the word log, it's going to use ln. Everything is still the same. If it asks you to condense it, we'd go backwards. That if you had the ln of x plus the ln of y, you would condense it back to the ln of x times y. So all those properties, all those things we were doing, it's the exact same thing before. Now it's just ln instead of log. So what they're going to ask you to do in some of these cases, they're going to ask you to rewrite as a single natural log. So they'll give you something like this, where we're doing ln of 5 plus the ln of x. Okay, so this is where we've got the two properties here. So if it's an addition problem, to rewrite it, we multiply those two things together. So this one would just be the ln of 5x. All right, may give you something like this, where we're doing 8 times the ln of 2 minus the ln of 4. All right, so this one's got two things. First off is, if it was just 8 ln of 2, we would take the 8, move it back on top of the 2. So we'd make it the ln of 2 to the 8th power. And if we do 2 to the 8th power, do 2 times 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 2, that's the ln of 256. All right, and then because it's ln of 256 minus the ln of 4, that's going to be 256 divided by 4. If you do 256 divided by 4, that comes out to be the ln of 64. All right, now in some of the cases, if they ask you just to rewrite it, sorry, I wrote it down a little bit harder. If they ask you just to rewrite it as a single natural log expression, that's as far as you'd have to go. Now, we'll do some in a little bit where it's going to ask you to simplify it, and that's where we'd actually punch that number into the calculator, and wind up showing what it's going to be here. Now, this is one I don't particularly like the way this one is, because it's already written this way. To me, this is where they should have gone back and said condense instead of rewrite, because this has already got just the one natural log in it, but they still want you to go back and rewrite it. So for that one, all right, so what we've got to do then is we're still going to take this 6 and bring it up here as the exponent. So that's the ln of 2 to the 6th power. Okay, so to me, it's kind of a little bit odd, because it's already just one natural log, and they're asking you to rewrite it as a natural log. So in that case, they're wanting you basically just to move this power up top on that one. That's the only one where they would have to do something like that would be just a little bit odd when it comes off of it. All right, and that would also be the ln of 64. Okay, so if they ask you to rewrite it, it's the exact same thing we were doing the other day, where that you just move some different things around. You use your different properties that you have to either, again, if it's a subtraction, that means you've got to divide the two numbers. If it's addition, you've got to multiply the two numbers. And if it's got a number out front, then that winds up being a power that you can pull back to it there. So exact same properties. Everything still works the exact same way. It's just now, instead of being log, now it's just ln. But it still works the same way. All right, now the one thing that is different about this one, here's where it's and just showing you this one little thing that's here. So if you need the moment of the day, here comes the moment of the day. That when they ask you to solve, there's really, I guess, two things you have to do depending on the problem. Again, when I talk about natural log, we're talking about xn. ln. That there's really just two things you've got to worry about here. And basically it's this. To solve a problem with ln, because they're either going to give you a problem that's got ln in the problem, or they're going to give you a problem that's got e in the problem. And we're going to look at both of those. But to solve a problem with ln, you're going to rewrite the problem using base e on both sides. Okay, so if you're given ln, you're going to rewrite it with base e on both sides. All right, and then the only other thing they can do is if they give you ln, you're going to take base e. If the problem starts with e, so to solve a problem with e, we're going to take the ln on both sides. Okay, so the other day it was one of those problems where if they gave you something that was, in the log problem, if it was log of whatever it was, base whatever, you rewrote it with this as the base on both sides. So this one we're basically doing the same thing. That if it's ln, that means it's base e. So we're going to rewrite both sides with base e. If we've got the e in this case, we're going to take the ln. And basically here's what it comes down to. This is the big thing that you have. If ln and e basically are together, then they cancel each other. All right, now, and it's just like when we're doing the squares and the square roots, that if we had, and again, you don't have to write this down, but just thinking that if we had, x squared equals 9, to solve this one, we would go back and square root both sides. This one's kind of the same thing. If we can get a square root and a square together, they're going to knock each other out and get x equals, and we just do whatever here. Same thing with this one. If we can get ln and e together, they're going to knock each other out. Or if you put ln and e together like that, they're going to knock each other out. Okay, now this is the kind of test question that nobody should miss this one, because this is like the easiest test question in the world. And you may be thinking I'm kidding, but I'm not. This is like easiest thing. If you've got this example written down somewhere, there's no way you can miss this problem. Okay, because there's a couple of them like this in the homework too. It's going to give you the ln of e to the 79. All right, and here's the thing. If you can get ln and e together, they knock each other out. So your answer is just 79. And somebody's thinking, what else you do? You don't. That's it. That's all you do. So if you're given a problem and it tells you to simplify, and it's the ln of e to the something, whatever this power is up here, that's going to be your answer. And that's it. That's all you have to do. Because if that's all you have, again, the ln and e cancel each other out. There's nothing else you can do to it. So now, again, there'll be one or two mixed in like that, just easy questions just to make sure you're on your toes. All the other questions that you're going to do, though, they're going to either have one or the other. They're not going to have both of them. So let's say you have something like e to the x equals 12. All right, so what we've got is if we can come up and get an ln and the e together on this one, we'll do this. So to do that, we're going to take the ln on this side and the ln on this side. So we've got e to the x is equal to 12. So we've got the ln of e to the x is equal to the ln of 12. All right, again, if we do that on the left-hand side, the ln and the e knock each other out. And just leaves you with x. And then from there, it's going to say, all right, write this answer in decimal form to 1 or 2 or 3 or 4 decimal places. And from there, it's just all calculator problem. Hit your LN button, put in 12, hit equals, and there you go. You got the number you're looking for. So this was 3 decimal places. That would be 2.485. If they went for 4 decimal places, it would be 2.4849. They'll tell you, and again, every problem I looked at, they were all a little bit different. Some of them were 1 decimal place, some were 2, some were 3. But that's all you got to do. Just use your LN button that's here. All right. On the flip side of that one, if they give, so that one you were given E, if they give you LN, well, we're going to do the exact opposite. So if we've got the LN of 4x equals 3, this time we're going to have to rewrite, and then back up here at the top, it said we're going to rewrite both sides with base E. So what we're going to do is we're going to put E as our base on both sides, and then you're just going to drop these two numbers down inside the exponent. So we're going to have E to the ln of 4x equals E to the third. All right, and again, if we can get E and ln together, these two things will knock each other out. So these with 4x equals E to the third. All right, and every calculator is going to be a little different where the log button is, but the log, the ln, and the E button are pretty much always together. If you look right behind the ln button, there's the E that's back here in green. So hit second and then hit E. And we need E to the third power. So that's like 20.0855 for that thing. It's 20.0855. Okay, but that's 4x. So then to get the answer, we've got to go back and divide by 4 on both sides. So then just take that answer and divide it by 4. So x is rounded off. That's 5.021. If we go to 3 decimal places. Okay, and every other question they're going to ask you is either going to be one of those two cases where it's either E or it's LN, and you just got to, figure out which one it is, and then you're going to take whatever one they give you, you're going to do the opposite to make everything cancel out. So if you've got, do a couple more of these. So you've got E to the x plus 1 equals 7. All right. So if they give you E, we're going to take the ln of both sides. All right. And again, for that one, the ln and the E cancel each other out, which is the whole purpose of doing that one. That leaves us with x plus 1 equals the ln of 7. And there's where it becomes calculator time. Just do the ln of 7. And that's 1.9459. Okay. And then all we got to do is subtract 1 from both sides. So just take that answer minus 1. And then x is, and if we round this thing off, that's 0.9459. All right, I'll give you one more of those, and that's about all we can do. Let's give you an ln on this one. Let's do ln of 7x minus 6 equals 5. Okay, so they give it E, take the ln. If you got the ln, got to rewrite it with E. Thank you. Okay, so for this one, got E for the base. We'll do 7x minus 6 and the exponent here and here. And again, the whole reason to do that is the E and ln cancel each other out. So that's 7x minus 6 equals, and if we do E to the 5th, that's 148.413. Again, you don't have to write all that down. Basically, just put something in there enough to know what it is, because then you're going to solve this equation from here. Once ever you get that number that's here, you're going to go back and add 6 to it. So you get 7x equals 154 point blah, 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 blah. And then you're going to take that number and then divide it by 7. So then we get x is about 22 point. Again, that'll take it around to 3 or 4 decimal places. In this case, we'll go 3 decimal places. 22.059. All right, and as far as it goes, that's all they can do. They either give you ln and you take the E on both sides, or they give you E and you take the ln on both sides. So whichever one they give you, you do the other one to it. They give you E, you take the ln. They give you ln, you got to use E. And again, once you put E and ln together, they cancel each other out. And then from there on out, it's just using your calculator to work it out and get through the numbers.